2008 Nissan Rogue. We have a check engine light on, and we have a DTC P2A00, which is for a air fuel ratio sensor bank 1 sensor 1 malfunction. So the first thing we're going to do is look up this DTC and find out what it's about. Alright, so let's read the description for the DTC P2A00. P2A00 Nissan air fuel ratio sensor circuit range / performance bank 1 sensor 1. Possible causes: air fuel ratio sensor, sensor bank 1, sensor 1. Air fuel ratio sensor, sensor 1 bank 1 sensor 1. Harness is open or shorted. Air fuel ratio sensor bank 1 sensor 1. Circuit poor electrical connection. Fuel pressure. Fuel injector. Intake air leaks. Alright, tech notes. If the P2A00 code is set after a sensor is replaced, check for exhaust leaks and perform the air fuel ratio self-learning procedure. When is the code detected? The output voltage computed by the ECM from the air fuel sensor 1 signal is shifted to the lean side for a specified period of time. Possible symptoms: engine light on, check engine light, duh. P2A00, this is the Nissan description for the sensor. Alright, so the air fuel ratio sensor is a planar dual cell limit current sensor. The sensor element of the air fuel ratio sensor is the combination of a nurse concentration cell, sensor cell, with an oxygen pump cell, which transports ions. It has a heater in the element. The sensor is capable of precise measurement, lambda equal 1, but also in the lean and rich range. Together with its controlled electronics, the sensor outputs a clear continuous signal throughout the wide range of 0.7 is less than lambda, less than air. That doesn't make any sense to me. But let's keep going. The exhaust gas components diffuse through the diffusion gap at the electrode of the oxygen pump and nurse concentration cell, where they are brought to thermodynamic balance. An electronic circuit controls the pump current through the oxygen pump cell so that the composition of the exhaust gas in the diffusion gap remains consistent at lambda, which equals 1. Therefore, the air fuel ratio sensor is able to indicate an air fuel ratio by this pumping of current. In addition, a heater is integrated in the sensor to ensure the required operating temperature of 700 to 800 degrees Celsius, which is 1,292 degrees to 1,472 degrees Fahrenheit. So basically, the computer of the car's computer calculates the air fuel ratio mixture by the current that is needed to keep the lambda sensor, the air fuel ratio sensor, at lambda, which would be 0. So if it requires more current to keep the air in the diffuser, or what is it called, the nurse concentration cell, if it requires more current to keep that at 0, then it knows to either enrichen the mixture or lean the mixture out based on the amount of current that's required to keep the concentration cell at 0. If that makes any sense, based on the current that's used from the pump. If that makes any sense. Alright, let's move on. We have a DTC for that. We've already confirmed that the air fuel ratio sensor is faulty by looking at the data stream and checking for vacuum leaks and exhaust leaks. We have no vacuum leaks, no exhaust leaks, no PCV system leaks. But when you look at the data on the engine for the air fuel ratio sensor, you can see that the air fuel ratio sensor is fluctuating dramatically, and that's a clear indication that an air fuel ratio sensor is faulty. Most air fuel ratio sensors, the data stream will be nice and smooth and steady until you blip the throttle and try and accelerate. Then you'll see some variations in the air fuel ratio sensor, but nothing major. It should be nice and smooth and steady. So what I'm doing right here is just want to show you what it looks like when you have a faulty air fuel ratio sensor. Alright, so let's go into the data monitor and select air fuel ratio sensor. Alright, so let's switch this to the line graph view so we'll get a better visual of what's going on. And as you can see right now, well, you'll be able to see it better once it goes over a little bit more to the right. You can see it's already fluctuating up and down, and that shouldn't be. It's going between 1.7 volts and 2.4 volts, and I'm not even touching the accelerator at all. Right now it should be pretty smooth, somewhere around 2 volts, I believe, if I'm not mistaken. And yeah, just that's me giving it some gas just to make sure that the sensor is responding. It does respond, so we do know that there's not a problem with our circuit. If you see some response when you give it gas, then you can pretty much rule out there being an issue with the wiring or something like that. Alright, so what we're looking at right now is the data for the air fuel ratio sensor after the air fuel ratio sensor has been replaced. And as you can see, it's much smoother. There's no large fluctuations up and down. The first few blips in that data stream, that's from me starting the car. It went rich for a little while and then it smoothed out, and I guess the second 2 blips were just the computer running some diagnostic checks. But as you can see right now, the data stream is a lot smoother, and there's no issues with the air fuel ratio sensor whatsoever. The only thing to do next would be the to clear the learning value for the ECM so that the computer can be able to better fine-tune the air fuel ratio mixture based on a new air fuel ratio sensor, because it's been running for X amount of time with a faulty air fuel ratio sensor, so it's learned some bad habits, and you know, the computer needs to relearn some good habits with a good air fuel ratio sensor. And that's that. Problem solved. Thanks for watching. Like, comment, and subscribe.